Wait, okay, share my screen. Mm-hmm.
So have you installed Kinter in your machine?
This one?
No, you can open your CMD first.
CMD.
You can type your pip install. Yeah, space TK. Yeah, enter. Okay, so you have the Kinter in your machine. Okay, now you
Mm.
can minimize and use a small case from Kinter import all.
Small
Line number
case.
line number 9. You can use small t in place of yeah.
Okay, small t. And then save.
Now you can save your code. Control S. Yeah, now you can.
Yeah, same. Maybe this one.
No, no. See, it was not defined. See, you have many windows open. So what you can do, you have to open the output panel. This part.
Uh, And then save again.
The code is already saved. You can run it.
Yeah, same.
Hmm. I think. Can you type LS here? LS.
Here.
Yeah, LS.
ls. Yeah, there is thinker.
You have your file name kinder.py, right?
This one, yeah.
This file name will not work because we have kinder library and you are saving your file name as a library name. So this will not
Oh,
go to work. So
okay,
you
let's
have to
save us. Save, save us a thinker module.
no, not you can just uh, use
Or
underscore
yeah, underscore
use module underscore one
module. Then
underscore
one.
yeah dot py.
That py.
Yeah, and remove this file. First save it.
Save it.
Yeah, and remove this file, which is open your location where this file is located.
Okay. On the desktop, Python. Let's take it there.
Yeah, this one. Remove it.
This one.
Yeah. And also change your folder name. Your folder name is itself is Python, and Python is a language. Like we have additional
Okay.
folder in your library in your machine, which is named Python. So your machine will get confused, like which Python to pick. So
Okay.
you have to change your name as
So
well, folder name. You just change the folder name there. With Python here. Yeah. Change it to any other name. You can put Python underscore practice. Python underscore practice. Yeah. You have to close your VS Code. Yeah. Now you can open.
mhm.
Now try to. Okay.
Oh, there you go. Oh, okay, yeah, it works now. Oh, so there's a conflict of a name.
Yeah, exactly.
Okay, I understand. Thank you very much, teacher. Yes, I'm good now. I
Okay.
can continue this. Okay. Okay. Do you want me to stop sharing now, teacher?
Yes, yes.
Okay. Okay, teacher. Thank you. Solve the problem.
Yeah. So always name your file, like just apart from the library names or the module name in Python.
Yes, I know, I know.
So in the last session, we have completed the Python Kindle library, which is
Mm-hmm.
for GUI. In this session, we will continue with the GUI session only, and we will study different library, which is known as Turtle. Okay, Turtle
Yes.
library is mainly used for making the shapes, animations, etc. So Turtle is a Python library which used to create graphics, pictures, and games. It was developed by Valley, and like these are all these developers of Turtle. It was a part of the original logo programming language. So Turtle is mainly used for creating the shapes, the graphics, the animations. Okay, and this logo programming was popular among the kids because it enables us to draw attractive graphs to the screen in the simple way. It is like a little object on the screen which can move according to the desired position, and that object is known as turtle. Okay, similarly, we have a turtle library comes with the interactive feature that gives the flexibility to work with Python. So turtle and Logo programming are like kind of same. Okay, so in the turtle library, we have many elements. So let's see. First, we have to install the turtle library. So we will see how we can install it.
Mm-hmm.
We can write pip install turtle. Let's install it.
Oh, even there, huh?
There's some problem in my machine. So let me check if data is there or not. You can import data. See. Let's save this file. Document. Display file. One. Hmm. Yeah, Turtle is there in my machine, but you can install it by using pip install Turtle. Okay, it is
Mm-hmm.
already there in the machine. So I can write here pip install Turtle. Okay, then we have to import the turtle. Now, how we can use it? So it is similar to the kind of Kindle library. First, we have to import it. Then we have to create a main screen. So we can use here a equal turtle dot get screen. This is for getting the screen. And then we have to run the main loop, which is turtle dot main. Okay, so we are importing turtle, then making the main screen, and then running a loop. So if I run this one, you will notice a window. See, this is your main screen, and this point there, this point is known as your turtle. So let me open the app. See, this one is your main screen, and this point is known as turtle. Okay, now we have to move this turtle in a shape, in a like direction that we can create any shape, we can create any animation. That is our main goal. Okay, so we have this important turtle. Then this is for getting the main screen, or we can say here, creating the main screen, and then running the loop, running the dot. Okay, so this is how we can create a window. Then let's say in the turtle we have four directions. Like a turtle can move in four directions: forward, backward, left, and right. So how we can move our turtle forward, backward, left, and right? So let's see. So this is for moving turtle in forward direction. So we can copy this code and bring here. So here we have this main screen, and then we have this main screen, and then we have this main view. So what we can do, we have to move the turtle in the forward direction. So here we can simply use A. First, we have to create a turtle as well. So what we can do, we can um, let's create a turtle first, not a screen. So we have this T equal turtle dot turtle like this. This is for creating the turtle. And then we can move the turtle, which is T dot forward. Okay, so we can move the turtle in the forward direction. Now, in the forward direction, how much we have to move? So let's put 100 here. So if I run this one, okay, now you can see the turtle has moved in the forward direction. If
Mm-hmm.
I run this again, you will notice it is moving in the forward direction, 100. If I increase the size to, let's say, 300, now you will notice the turtle is moving in 300, in forward direction 300. So it is like a direction loop. You can see here, we can use forward direction, or we can use t dot forward or t dot fd. They are same only. Okay, like here in place of t dot forward, we can also use t dot fd. They are same only. Either you can use forward or you can use
Mm-hmm.
fd.
FD. Okay, teacher.
Let's see if it is working or not. The same it is working. So either we can use forward fd or we can use forward. They are same only. So here I can write same as t dot fd. Yeah. This is for moving in the forward direction. Now we can move in the backward direction. Like we can make our turtle to move in the backward direction. So here we can again copy this code here and we can write this is for backward direction. And here we can use VD for backward. Let's try here. So now we are going to move the turtle in the backward direction. So here I can run this code. We will notice it is again moving in the backward direction. Is the animation. Sorry, I just uncombine this.
Mm-hmm.
Now we can run this one. Okay, now it is moving in the backward direction. So this is how we can make the turtle to move in the backward direction. And we can also use BK. Okay, we can also use VK in place of backward. So this will work same as backward. Either you can use backward as a keyword or you can use BK. They are all
Mm-hmm.
same. Okay, either backward or BK.
Yes, teacher.
So this is for moving in the backward direction. Then we can make our turtle to move in the right angle. So this is for moving turtle in right angle. So again, we can create a turtle is turtle dot turtle. And for moving in the right direction, first we have to head forward. So let's say t dot heading forward. Okay, and then like you have to define a head of the turtle, and then we can use here t dot right, which is right angle. Let's say to 25 degrees, and then we can again define a heading. Okay, and then we can use a main loop.
Hmm. Turtle that window.
So let's run this one. See, this one is heading, but not moving.
Because the right is only 25.
Let me see. With this heading, see this angle is moving, but it is not moving here. See here, this angle has been changed. The total angle was this one. Now it is changed to this one. So that is it is heading, but it is not moving. I think we have to. What if I move this to right?
Or can we put a value of T heading, teacher?
Sorry.
Can we put a value after that heading? Yeah, inside the closing parentheses. Yeah, maybe. Let's see.
No.
Oh.
Heading will not take any argument.
Mm,
What we can do in place of heading, we can put right here. If we don't
okay.
right. Sorry. Forward. So first we are making the turtle right and then forward. Okay, now it is good. So this is how we can move the turtle in the right direction and then forward. It is like an angle here. If I change the angle to 90 degrees and then move forward, you will see, okay, it is
Yes.
now moving in the downward direction.
Mm-hmm.
Then same as we can put the right angle at left side. So with this, in place of right, we can put left here and then again forward. So now it will move in the upward direction. Opposite of
Mm-hmm.
right means left. Okay. So either we can put left and or right. So we have this left or we can put right. Hmm. Okay, but we have to put one at a time, either left or right. Okay, what we can do is we can first put left and then we can move forward and then we can put right and then we can move forward.
Oh.
Okay, this we can. Okay, we will see this example later on. But for now,
Mm-hmm.
we can move forward in the forward direction. We can move in the backward direction, right
Mm-hmm.
direction, and left direction. Okay, then we
Yes.
have this the series initially divided into four quarters. The total is a position at the beginning of the program is 0, 0, known as a home. For example, let's say we have a screen and our screen is divided into four quarters like this.
Mm-hmm.
Our total is here at 0, 0.
Yes, teacher.
So now the turtle can move in this direction, this direction, this direction, and this direction. So these are quarters. For example, this is x-axis and this is y-axis. Now, if my turtle wanted to move in this direction, this one, then I have to provide a value of x and a value of y, like this. Okay,
Mm-hmm.
value of x, let's say this can be 5, and value of y. This can be, let's say, 3. Okay, so 5 comma 3, like this one. So this
Mm-hmm.
will move in this direction, like this. Okay, so let's see. We can move the turtle in any four quarters with the help of go to keyword.
Go
This
to.
go to.
Yeah.
So let's see. We can copy this code, right? And we will. Now this is moving the turtle in quarters. So in place of this one, we can put go to. Okay, so now here we can provide any value like how much we have to move. So let's say 100, comma 50. So let's, okay, now see, it is moving in this direction, 100, comma 50, which means if this point is 0 or comma
Mm-hmm.
0, so this is 100
Mm-hmm.
and this part is 50. So 100, comma 50, like it is how it is moving. Okay. So next we can also move in any other direction. Let's say 300, comma 80, like this. And then again we can run it. You can see it is moving this
Mm-hmm.
direction. Okay, now with the help of all these like directions and this go to object, we can create a shape. So let's try to create a shape here. So this is drawing a shape. Okay, any shape we can draw. So let's say we have turtle object and then we have main wheel, which is turtle dot main. Now in between we can create a shape. So let's create a square. So we can use FD first, which is move forward to 100. Then we
Mm-hmm.
can change the direction to 90. Then we can move forward 100 and then again we can change the direction to 90. Then again we can move forward 100 and then again we can change the direction to 90 and then again we can move forward. Okay, these are my commands. That if I run this one, you will notice a square. Okay,
Oh yeah. Oh.
so this is first first moving this side and then changing the direction, then moving, then changing the direction, then moving, then changing the direction, and then moving like this. So that is why we
Oh.
have these bunch of values. First forward and then changing direction, then forward, then changing direction. Like 4 times we are doing this one. Okay. So this is how we can create a shape. Let's create a circle. So how we can create a circle? So this is a drawing a shape, a square. If I wanted to create a circle, then I can put here turtle and then there's a command for circle, which is t dot circle, like this one. Now we have to provide the radius of the circle. Let's say the radius should be 60. And then we can create the main like this. So this will automatically create your circle. See. Okay. Is it clear?
Yes, teacher. Very cool. Circle.
Now let's say if I wanted to create a dot circle, like see, if I put here in place of circle, I put t dot dot like this again 60. So this will fill your circle in any color, in black color. This is our dot. Okay, it is too much speed. So it will create a circle and then fill the color, black color in the circle. So that is a dot here. So we can also create a dot with the help of t dot dot or a
Mm-hmm.
circle. Okay. So they are like kind of same only. Now, if I wanted to change the color, screen color, so how I can change? So this is changing the screen color. Let's say I just wanted to change the screen color to any other color. So first we will create a pattern. And then here we can use turtle t dot bg color. Sorry. Data here dot bg color, and here we can provide a color, let's say blue, and then here we can run the main blue. It's called. So this will turn the screen color to blue. It's blue color. Okay. Same as you can provide any hex value to the color, like any hex value here. Let's say red here. Now the color will change into red color. Okay, now let's say I just wanted to provide a hex value to the BG color. So we can take any hex value from the let's say hex color. So we can take any hex color to for the value. Let's say this orange color. So we can copy the hex value of this one and we can paste here like this. So this will turn the color in orange color, like the screen in orange color. Okay. So we can also take any hex value from the browser, from the color picker, and you can put your hex value on your screen like this. So this is how we can change the color. Now let's say I just wanted to add an image to the screen. So we can use adding the image to the background. So how we
Mm-hmm.
can add the image in the background. So first I want the image. So let's say we can download any image. Let's say tree image. Let's say I just wanted to put this image. So we can download this image. We can right click, save image as, and we can put on desktop. And let me change the name of the image. Let's say image.jpg. Okay, so we have this image. Now here we can again create a button. And then we can run a main loop. And in the middle, we can put an image. So for putting an image, we can use turtle dot background pic. And here we can put the name of the image. Okay, which is dot jpg. So you can see my image in the same location. This is my file and this is my image. So they are in the same location. If your image is in the different location, then you have to provide the location of your image. You have to click
Mm-hmm.
on the properties and you have to copy the location of your image and then the slash name of your image. If your image is in the different location.
Mm-hmm.
Okay, now we can run this one. Image dot return image. File name. Image dot jpg. JPG. Let's use any other image. Let's say with this image. It is not an image. Um, let's try with this image, which is this one. So here we can put a BGP. Again, not working. I think this will take image in the PNG format. So you have to download PNG image. Let's say with this image, you can right click, save image as. Yeah, it is a PNG image. So let's add this one, tree.png. And here we can put, yeah, it is working. So the BGPic always take the
Wow.
image in the PNG format. Okay, you can see we have this image here. It will always take image in the PNG format, not in the JPG format. Okay, that
Oh,
is
PNG.
kind of
Mm-hmm.
like we were putting the image in the JPG, but it always take in the PNG format. Okay,
Yes,
so
yeah.
that is how we can add image uh,
A
in the
turtle.
prompt.
Yeah.
Now let's say I wanted to change the size of the screen. So we can use screen size as a parameter here. So let's put here only. So this is image. And here we can change the screen size. So we can use title dot screen size. And we can provide our screen size. Let's say 500, 1000. So this is for changing the size of the screen. See. Okay, now if I wanted to now, you can see the size of the screen is too much. If I reduce it to, let's say, 800, 800, a square. So if I run this again, we will notice a small screen, a small screen. If I reduce again, like let's say we can put here 300 by 500, let's say, and we can run it. You can see the screen size is keep on reducing.
Mm-hmm.
Okay, so we can change the screen size as well with the help of screen size. We can also change the screen title. So we can put here title dot title. We can put our title, let's say demo title screen or any title. So if I run this one, you will notice a title here. See this one, demo title screen. There's a title. So we can put any title of our choice here. So this is for the title, and this is for the screen size, and this is for adding the image.
Mm-hmm.
Okay, now then we can also change the pen size of that title. So let's see this one in the different. Let's copy this one and make this. Now this is called changing the pen size. So we can use your T dot pen size. Let's say 5 here. So if I run this one, you will notice no difference. But if I forward it to 100, so you will notice the pen size. It will become thick.
Mm-hmm.
Okay. If I increase again, let's say 10, so this will become more thick.
Speaker. Yeah.
See, this is the
Mm-hmm.
pen size. So this is how we can change the pen size uh of this pen. We can also change the pen color. It is again simple to change. We can change the pen size, pen color, and pen shape, like everything. So let's say
Mm-hmm.
if I wanted to change the pen color, so I can use here t dot fill color. Either we can use pen color or I don't know, various colors. Let's see. Okay, you can see the pen size has been changed. Also, we can put in place of pen size, we can put fill color right here. Fill color. Fill color. Let me mention the pen size. See, there's a difference in the pen color and fill color. If you notice, let me apply the fill color as pen color as well. Dot pen color to let's say let's say red. See, this pen color, the line we are drawing is of red color, but the arrow, this one is of blue color now. Okay, so blue color means the fill color. Okay, the
The
arrow color here,
turtle.
and pen color is the line color. Okay,
Mm-hmm.
is it clear?
Yes, teacher.
And we can also change the shape of the turtle. So here we can use, let's say, t dot shape size. Let's say we can provide 5, 5, 5, three values. And let's run this one. Okay, now you can see the color has been, the size has been increased. Okay, like why 5, 5, 5? Because we have three sides. 5 here, 5 here, and 5 here, like this. Okay, because we have 1, 2, and 3. Okay, so that is why we have 5, 5, 5. We have changed the color of three edges. One edge, second edge, and third edge. So these are
Mm-hmm.
5, 5, 5. Okay. So this is how we can change the shape of the color. Like shape and the color and the pen size. Is it clear this much?
Mm-hmm. Yes, teacher.
Okay. Now let's see what is remaining. We can draw the shape. We can change the color, image, background, color. This one is. We have this turtle fill in the image. Like we can also fill the shape with the help of this code here. So let's try to run this one, this part. This is change the pen size, pen color, fill color, and shape size.
Mm-hmm.
Now we have this code here. This is for filling the shape with the help of this part, with this begin fill and end fill. So if I run this
Mm-hmm.
one, you will notice, see, and you can see
Oh.
this, we are just filling. First, we are drawing the shape and then we are filling the shape with the help of this black color. So that is end fill and begin fill and end fill.
Mm-hmm.
Okay, like again, if I run this one, you will notice first it will draw a shape and then we are filling the color. Also, we can change the shape of the turtle to any other shape. Like now the turtle is in like in the arrow format. We can also change the turtle shape into circle. So let's say we have this changing the turtle shape. With this we can run the menu here. Now here we can provide a shape. Let's say t dot shape in the circle format. So now you can see the turtle shape will be changed to circle. So now it is in circle shape. If I put here arrow, so this will change into arrow shape. Okay, which it was before. See, it is an arrow shape.
Mm-hmm.
So we can change into square as well. I think. So let's see. It is in the square shape. So we can change the turtle shape. Also, we can change the speed of the pen. Okay, like we can change the speed of the pen, like how the pen is moving. So let's see the speed of the pen. For example, let's say we have this shape here. Okay, let's copy this part here and let's uncomment. We have this square shape. So if I run this one, you will notice a square. Okay, now you can see this is like a very fast speed. So we can change the pen speed. Like we can slow down the pen speed. So there we can put t dot speed and to 3. Okay, we have this 1 to 10, so we can provide 3. And we can run this. See, you can see the speed has been reduced, right? If I again put here speed 1, and if I run this one, you will see a lot slow speed. So we have this speed here. Okay, so you can either slow down or you can increase the speed. The speeds vary from 1 to 10. 1 is the slowest and 10 is like the fastest speed.
Mm-hmm.
Okay, so this is how we can change the speed. Then we can customize everything in one line. Okay, like we can do every step in one line here. Let's say, so here we can use customize in one line. So
Mm-hmm.
let's say we have a turtle here. Okay, we have a turtle here. Now let's say first I wanted to change the pen color of the turtle. So let's say the pen color should be blue color. Then I can change the fill color to orange color. So we have this pen color and then we have this fill color. Then here we can change the pen size to 10, let's say. Then we can change the speed to 1. And then we can start filling the that shape of the color. And let's say let's draw a circle here of 50 radius or let's say 100 radius. So this will draw a circle. And then we can also fill the background color to BG color to let's say blue here. So we have this background color. And then we can end fill. Okay, we are here we are filling the circle and we are drawing the circle and then we are changing the background color of the screen and then we have this end fill. And then we can run the main loop, which is turtle.main. So we are customizing everything in one line. Okay, this is like a kind of doing everything in one line. So you can see if I run this one, you will see everything in one line. So here we are drawing the circle. You can see the line color is blue. The pen color is blue and fill color is orange. I mean, this is fill color. This background color is blue. And even the line color is also blue. Okay.
Mm-hmm.
So we are doing everything in one line. We are changing the speed, changing the color, changing the size of the this pen size and so on. Okay. So this is like customizing in one line. So whatever we are doing here one by one, we can do everything in one go. Okay, so this is how we can customize in one line. Then we have, is it clear this much?
Yes, teacher.
Then we have this change in the pen direction. So we can also change the pen direction. There are 4 direction, up, down, okay, and left and right. So let's say we can create an object, turtle, and then we can run the main wheel. Now we can put everything in the middle. Let's say I just wanted to move forward 100. Then I wanted to change to 90 degrees. Then again, here I just wanted to move the pen in upward direction, which is pen up. So this will move the pen in up direction. And then again, we are moving forward Okay, and then we are moving forward and moving right. And then again we are putting pen down. Okay, we have pen up and pen down. And then again we can do the same step up to here. Pen up and pen down. So if I run this one, you will notice. See, what is the meaning of pen up? Here we have moved in the forward direction 100. Then I have changed the position to this angle 90 degrees. And here we are moving pen up. Pen up means the pen is not moving here. It is in the upward direction. We are not moving here. Then pen down. We are changing the direction again. And then pen, we are like making the line again. And then pen up again. And then pen down again. So it is like we are just, when the pen is up, so we are not drawing anything. And when the pen is down, we are drawing something. Okay, so when the pen is up means we are not drawing anything. But when the pen is down, we are actually, the pen is on the paper and it is drawing something. So that is the meaning of pen up and pen down. So when the pen is up, we are not actually drawing anything. Okay. So this is like uh, changing the pen direction. Then we can also clear the screen. If you wanted to clear the screen, then you can put clear. Let's say here we have this t dot clear for clearing the screen. So whatever you have done, you can clear the screen again. See,
Mm-hmm.
we have this one, and then you can see that the screen has been cleared.
Oh.
Same as in place of clear, you can also put t dot reset for resetting the screen. Either you can put clear or you can put reset. So they are same only. Then we can also leave a stamp, which is leaving a stamp. Leaving a stamp means, let's say, let's create a filter. Let's create a main. Okay. Now let's say if I use t dot stamp, and then let's say I'm moving forward 200, and then again I'm leaving a stamp, and then again moving forward like this. So stamp means this will just leave the turtle sign there. Okay, so if I run this one, you will notice like these steps. So these are leaving. Okay, this turtle sign. This arrow
Mm-hmm.
is leaving here, here, and here, like this one. So this is a kind of a leaving a stamp. Okay, then we can also clone a turtle if we want. So we can clone a turtle like this. So let's say we have this turtle here, and then we can run a main loop with the help of turtle dot main loop. And then here in the middle, we can use c dot c equals t dot clone. So here we are cloning a turtle. Okay, and that we are providing in the C variable. Now let's say where this first we have t dot color. Let's say color is blue for the first turtle. And let's say we have the second turtle. And here we can provide red color. So we have two turtles now. First turtle is T and second color, turtle is C. Then let's say we are drawing a circle with the help of T turtle. Let's say the radius is 20. And then we can drawing a circle with the help of C. Okay. Now you can see if I run this part, you will notice two circles. Okay. First is clone one and second is, sorry, first one is the original and second one is the clone one. Okay. Now we can see you can also like run a loop here, like circle inside circle. So here we can use for I in range, and I wanted to move turtle in 40, 100 direction and 10 times. Okay. Like 40 is the start position, 100 is the end position, and then 10. Okay, it is like taking the step 10. Then we can use. And Okay, now you can see we keep on moving. Let me show you again. See, we keep on creating the circle like this one. So this will keep on moving in this direction. Okay, you can see this blue circle is of original turtle and this red color is of uh that is of clone turtle. And we are moving the clone turtle in this direction 50 times. Okay, why 50 times? See, we are using a sign here, which is we are using a loop here that it will start from 40. Okay, 40 is the size of the original turtle, 40, and then 50, 60, 70, 80, and 90 up to 90 because 100 is like to the last value, and we are providing 10 step, which is it will move like this one. These are radius actually 40, 50, 60, 70, 80 up to 90 like this one. So that is why it is moving 5 times. Okay, so this is how we can clone a turtle. Also, let's see an example of how we can use a turtle with the help of for loop. If I wanted to create a turtle with the help of for loop, so let's see. With this turtle here, we can use for I in range and we can use 4 times. Okay, I just wanted to run 4 times and 4 times I wanted to run this part. I wanted to move forward 100 and I wanted to change the direction to 90. Okay, and then I can run my main loop. This means I'm creating a square here with the help of for loop. Previously, we were creating a square like this one. Okay, like this one. This is like a square here. And this contains many lines. And all are repeated here. So what we can do, we can do the same with the help of a for loop. And we are running four times. So you can see we are creating a square here. But with the help of for loop. Okay, same as we can do with the help of while loop. So let's see the same with the help of while loop. So this is my for loop. Here I can use n equal 10, which is 10 times. And here I can use while if n is less than or equal to 60. So we are creating a circle and we are using t dot circle up to n times. It is 1, 2, like 10, 20, 30, 40, like this one. And then we are increasing the size by 10, like this one. Okay. So this will create a circle. This will run 50 times. Okay, like this one. Third, fourth, and fifth. 5 times. And 6. Okay. So first it will create an initial circle. This is of 10 size. Then this is of 20, 30, 40, 50, and 60. Yeah, up to 60. So this is like just creating a circle, 60 for 60 radius. And it will keep on moving. So this is 10. Then it will increase the radius size to 20. So this is 20 and 30 and 40, 50, and 60 like this one. So we are increasing the radius size as well. That's okay. So this is with the like this one
Well,
while loop. Okay. Now let's create an animation with the help of a turtle. So whatever we have used up to here, we can create an animation with the help of a turtle. So let's see. This is animation. What? So let's see. We have a turtle. Again, we can create a turtle here. Dot turtle. And here we can run the name. Now whatever we wanted to do, we will do in the middle. So first I will define a background color of the turtle. Let's say blue black. Okay, now the background color of the turtle is black. Then we can create a pen size for the turtle. Let's say 2. Then we can define the speed to 0, a very minimum speed. Then we will run a while loop. While true. Because we want in the iteration while true. So we will run a for loop inside a while loop for I in range. We want to run this in the 6 times. Okay, and here we can define the colors. For colors in, and here we can provide a list of the color we want. So first, let's say the red color. Second, we can put, let's say any color, orange, comma, we can put a magenta, comma. Then we can provide a white color, comma. Then we can provide green color, comma, yellow. Okay, so we are running the loop 6 times. 6 times. So we want 6 color. 1, 2, 3, 4, 5, 6. 6 color. Okay. So for I in range and for color, and then we can pick any color, which is turtle dot color, and this will take colors like this one, which are in the list, these colors. And then I will create a circle, turtle dot circle, and then I will move the circle, turtle the left side, which is turtle dot left to 10 degrees. Okay. And also I just wanted to hide turtle. So the turtle will be displayed. So I just wanted to hide the turtle at last. So hide turtle. So this is my one animation. If I run this one, you will notice a beautiful animation like this. I think something is wrong because
Uh-huh. There's no moving, huh? There's no moving teacher, right?
so if you here have to use
Oh,
turtle here, not a teeth. That is the issue.
okay. Make it a circle. There you go.
Yeah.
There.
Let me increase the speed. The speed is so slow.
At looks non-stop, huh, teacher?
Sorry.
Looks non-stop.
No, no, it will take a whole circle. Let me show
Ah,
you.
a whole circle. Yeah, okay, okay, okay.
Let me increase the speed to here. The speed is very slow. Again, it's increasing
Yeah,
it
more
to
than.
5.
Yeah, make it 5. That's good.
It is again slow. Let's remove the speed parameter from here to fun. So this will going to take the whole circle, okay, up to
Mm-hmm.
here, this part. So I'm stopping it because this will take time. So see, this animation is very easy to create. We just run a for loop,
Mm-hmm.
and inside this for loop, we have just pick the colors, then create a circle of 100 radius, and then left. If I increase the left to, let's say, 60, and if I put the speed, sorry, here I put total speed. That is why it is not working. Let's say 9. Now we can put 10 here. Never mind. We can put, if I increase the left to, let's say, 50, so you will notice it will take bigger circles, like a kind of a, it will move more left side like this. Okay,
Mm-hmm.
because this circle is of this one, and here this distance is of
Mm-hmm.
50. Okay,
Shitty.
these distance are of 50 up to
Mm-hmm.
here. Yeah, this is for forever. This loop will run
Mm-hmm.
for forever because
Yeah.
here I'm using the true here. Why true? So there's no false condition, so that's why it will move on. It will keep on moving. So you can also put a condition here. So now let's take another example. Let's say get this animation number second. Again, we will going to create a turtle object. And then here we will use turtle dot image. Okay, now let's try with the, again we can provide a background color to screen. Oh, sorry, to black. And then here I think can provide a pen color. Hmm. Let's create a screen here as equal turtle dot screen. So now we have screen also. Now let's say we want the screen color to be a black color. So here we can put s dot screen color to be black color, and we want the pen color to be red. Okay. Then we can start creating. Let's say we have two variable a equals 0, b equals 0. And here we can speed up the process again, t dot speed, and we can provide a speed of, let's say, 2 here. And then we can use a pen up direction, okay, which is, we don't want to move the pen for now. We want the pen, first the direction we go to the, in this direction, which is 0 comma 200. Okay, first I wanted to change the direction, and then I just wanted to pen down the drawing. And then here I can use a while loop. Again, this is forever 2. And then here we can move forward to A direction, and then we can move right to B direction. And then we can keep on incrementing the value of A by 3 and value of B by 1. Okay, so initial value of A and B are 0, and then we are incrementing by 3 and by 1. And then here I can use if B is equal 210. Okay, then we are breaking the loop. So this will stop the iteration. And then at last I'm hiding the turtle. And here we can use turtle dot done. So now let's see if this will work or not. Yes. So this will create a web-like structure inside the
Mm-hmm.
circle. like this.
Mhm.
I think, let me remove this for now and let me increase the speed to,
Yeah,
yeah, now
more
it is
faster.
working. Like this. So this will change on, keep on changing the shape of the,
Mm-hmm.
keep on changing the angle and then moving forward by 100. So this is the kind of another animation. Okay, and when the line will come on top of each other, then the loop will stop. Is it clear, this one?
Mm-hmm. Yes, teacher. But there's no non. It's a non-stop, huh, teacher?
No, no, it is not non-stop. See, now it is stopped. So we have
Oh,
put a
okay.
condition there that
Wow.
if the angle becomes 210,
One
then
zero. It will
we will
stop.
stop
Yeah.
because B is our angle. So it will move right. If line will come on
Mm-hmm.
top of each other, then we can see the loop will stop. Okay.
Mm-hmm.
So this is another example. Turtle is not important for it is not that much important. It depends on the scenario, like where you are using. But it is
Mm-hmm.
important to know that this one more library for creating the animations.
Mm-hmm.
Okay. And last example here, this one. So you can try this by yourself. Example number
Yes.
3. Okay. Try to run this one. You will find again a beautiful animation. Is
Yeah.
it
Let me
clear?
try. Yes, teacher. Very clear.
Okay. So I will share this file and this notepad file so that you can try it by.
Mm-hmm.
Okay. Now we can move. We have one project left for the Kinder that we will do tomorrow. Okay, the
Yes, teacher.
project for the Kinder. So we will
Mm-hmm.
do the Kinder project and the networking project tomorrow. Today we will take
Hey.
the introduction of networking as well.
There you go. Thank you very much, teacher.
No, we have the class. We have to resume.
Ah, okay, okay, okay. I thought.
I'm just saying that for the projects, for the networking projects, and for the Kinder project, we will do tomorrow. And we will
Okay.
take the introduction to networking today only. Okay, so that we can continue with the project tomorrow.
Okay, teacher. I got it.
So, what is the purpose of Python in the networking? With the help of Python, we can create many networking applications. We can automate the networking part and so on. So, Python provides two level of access to network programming: low level access and then high level access. Like low
Mm,
level access is like we can create the connections. Okay, like at low level, you can access the basic socket support for the operating system. Like we can create socket programs. We can implement a client and server program, and we can make that program connection orientated and so on. Then at high level, it allows to implement protocols like HTTP, FTP, etc. So in our networking session, we will see the low level access, which is important. Okay. So for this, we have to understand what are sockets. So let's say we have a bidirectional communication protocol. Let's say we have a client and then we have the server. Now the client is communicating with the server and server is also communicating with the client. That is a bidirectional. So the sockets are the endpoints of this communication channel. These endpoints can communicate within a process, between processes on the same machine or between the processes on a different machine. So sockets are used different protocols for determining the connection type of from port to port communication between client and server. So sockets, let's say we have a client here and we have a server here. Now the client can communicate with the server and the server can also communicate with the client. So how they
mhm,
are communicating with the help of sockets?
mhm.
Sockets let them communicate with the help of the port number and the IP address. It is like a port to port communication. And with the help of
Okay.
socket, we can implement that in the Python. Like we can create our own client and we can create our own server with the help of sockets. Okay. And
Okay.
that is known as socket programming. So to understand Python socket programming, we need to know about three interesting topics: socket, server, and socket client and socket server, like socket and client socket. So what is a server? So we know what is a server. A server is a software that waits for the client request and server or process them accordingly. It is like a server wait for the request coming from the client side. It will accept the client request and then process on the basis of that request. Like response, provide the response on the basis of the request. On the other hand, what is a client? A client is a person who requests for any services. That is a client. So a client program request for some resources to the server and the server respond to that request. That is like a
Mm-hmm.
simple definition of client and server. Then we
Mm-hmm.
have a socket. Okay. Now socket is a endpoint for a bidirectional communication channel between the server and the client. So you can think of a socket as a kind of mechanism which will let the client and server to communicate. Sockets may communicate within a process. It can like communicate within a process, or it can also process between the processes. Okay. Yeah, between the processes on the same machine or between processes on the different machine. For example, we have a client and we have a server. So now if the client and server are communicating, so they are communicating within the processes. But let's say if we have a client, we have many clients and we have one server. So now the client is communicating with a single server. So this is between the processes on the same machine. Okay, or we can see between processes on the different machine. So that is like socket. It can provide communication between the process, within a process, or between processes on different machines. For
Mm-hmm.
any communication with a remote program, we have to connect through a socket port. That is a socket port. So we have two modes in the socket that we will see. Socket programming is a way of connecting two nodes on the network to communicate with each other. One socket, which is a node, listen on a particular port at an IP address, while the other socket reaches out on the other to to form a connection. It is a one will wait for the request and another will send the request. That is, the server will wait for the request and client will send the request. And the server forms the listener socket while the client reaches out to the server. They are the real backbone behind the web browsing. This is how the web browser works. In the simple terms, there is a server and a client, and we can use the socket model for socket programming. That is like the whole theory. It is like we will create a server with the help of socket, and we will also create a client with the help of socket. And then we will connect the client and server together. And when we are connecting the client and server together, that is known as socket programming. Is it clear?
Mm-hmm. That's it. Yes, teacher.
Okay. So we have how we can use socket. We have to import socket. And before importing, we have to install it. So we can simply use pip install socket.
Mm-hmm.
Pip install socket. So this will install the socket library. I think socket is already there in the
Done. Okay. Oh, socket install, huh?
yeah sockets. They're like sockets. You have to put S.
Mm-hmm.
So that will install sockets. Okay, so you can write pip install sockets. Basically, they are like pre-installed in the machine. So we have to import the socket. Now for
Mm-hmm.
creating a socket, we have to use socket.socket method. Okay, now what is the syntax here? See, we have to use socket.socket and we have a socket family. We have to define a socket type and a protocol here. Now what is a socket family? We have two family, AF Unix and AF INET. Okay, that we will discuss tomorrow. What is Unix and what is like INET? Okay,
Mm-hmm.
they are like TCP and UDP. You can think of a TCP and UDP. Then with
Mm-hmm.
socket type, it is a sock stream and sock DG which is like a how we are streaming. It is like we are streaming with the help of packets or we are streaming with the help of datagrams. So that is socket stream of socket dgram. Then we have port number which is default is 0. Then we have this Unix. Unix are like files here. Okay, and iNet is like multicast, broadcast, or unicast. Okay, if you are
Mhm.
sharing any file, you can use Unix. If you are sharing, like if you are making the connection as a multicast or broadcast or unicast, then you can use iNet. Okay, mainly we use iNet only because that is like we can use the connection bidirectional, unidirectional, or we can use as a broadcast or multicast packets. So mainly we use iNet. But let's say you are transferring any file, then you can use AF Unix. Okay. Then we have stream and digigram. It is like connection oriented and connectionless. Stream is like connection oriented, which is TCP. Digigram is connectionless, which is UDP. So it's
Mhm.
your choice whether you wanted to use TCP, which is a connection oriented protocol, or UDP, which is a connectionless protocol. So we will use stream, which is a
TCP.
kind of a TCP. Okay,
Mhm.
and port number is default. So this is an example uh, of a server, of a Python socket example. So see, this is like a kind of flow we are going to follow. Python socket server program execute at first and wait for any request. So we will create two files, one for the server and one for the client. The server file will run on server and client file will run on client. First, we will execute the server file and the server will wait for the connection. Okay, connection from the client side. Then we will run the client program and the client will initiate the conversation at first. So then we will run the client file and client will send the request to the server. Then server program will respond on the basis of the client request. Okay. So this is like the initial message. We have the server. First, we will going to run the server. Then we will going to run the client. First, we will going to run the server and server will wait for the connection. Okay, the server will at the waiting waiting for the waiting condition. Then with the client will then we will run the client Python program and client will initiate the connection, which is client will share the request first and the server will respond with the on the behalf of this request. That is like the initial flow.
Mhm.
Then at last, whenever we wanted to end the connection, the server client program will terminate if the user enter by. If the client
Mhm.
enter by message, so the client will enter the by message, and then the server program will also terminate when the client program terminates. Okay, like when
Mhm.
the client will say bye, the, the client will stop the program, and as well as the server will also stop the program. Okay, so this is like a kind of a optional. We can also make the server running. Okay,
Mhm.
or it depends. If the client terminates the connection, it's your choice whether you wanted to terminate the server connection or not. It's your choice. So it
Mhm.
is like for initially we will when the client request the buy, like send the buy message to the server will also terminate. So that we wanted to do. Okay, let's say we have multiple clients here. We have two more clients here. Here we have the client and here we have client. Now let's say this client apply buy. Now, but this client is also running and this client is also running. So in that case, we cannot let the server to terminate. Okay. So it depends on the scenario. It depends on the scenario.
Mhm.
So let's see the server code first and then we will create the client. Okay. Or we can first create the client because client program is easy. Then we will
Mhm.
create the server.
Okay.
So in the server method, we have many methods here. For the server, we have bind method, listen method, and accept method. Okay, these three methods. Bind for binding the socket, like binding the address with the socket. For example, we wanted to bind the IP address and the port number. That is binding. We will take a IP address and we will take a port number. So we will bind the IP address and the port number together with the help of bind method. Then the server will listen for the client. Like listen method will the server will listen for the client. It will wait for the client. That is a listen method. Then accept, the server will accept the connection coming from the client side. These are the three functions of the server side.
Mhm.
Then we have some functions from the client side, which is as.connect. So this will connect like send the connection request to the server. This is the client method, and these are some general method. Okay, some general method used for both client and server. First for sending the TCP message, sending for the UDP message. Receive, this is for receiving the TCP message, and receive
Mhm.
from, this is for receiving the UDP message. Close, this is for closing the connection, and
Mhm.
get host name. This is for getting the host name, the name of the client. Okay, that is the host name. So these are the methods we are going to use in our client and server programs. Is it clear this much?
Yes, teacher.
Okay.
Very
So
interesting
first,
now.
yeah, first we will going to create the client. Then we will going to create the server. So
Mhm.
I will create a new file here, a Python file. So first we will import the socket.
Sakit.
Okay. Then here we will create a function def. This is a client underscore program, a function here. Okay. Then first we have to provide a IP address. Okay.
Mhm.
So here I will use a host equal. Here I will provide a IP address. And then here I will provide a port number. Let's say port number is 1224. IP address I will later provide. Then we have a client underscore socket. This is my object here. So here I will create socket dot socket. This is for initiation. Socket dot socket is my class, and I am initiating inside my module, inside my object. So technically, this client socket is a reference variable. Okay, but here I'm creating an object, and then I will use client underscore socket dot connect. I just wanted to connect with host and port. So here comes my host, which is my IP address and my port number 1224. Okay. Then here I will type a message. Message equal. I will take a message from the user, which is input. Okay. So input your message like this one. So we will take a message from the user. Then we will run a while message dot lower. Okay. Message dot lower dot string is not equal to by. Then this loop will keep on running. If the user type by, then we will stop the loop. But if the user type anything apart from by, then this loop will keep on running. And how? See, if I run client.socket dot, here I can use send. So I will keep on sending the message. And for sending message, you have to encode the message. Okay. So this is for sending the message. We have to encode the message. And then we have to define the size of the message. Like how, like which size we can receive. So let's say if I wanted to receive the message from the server side, so I will define a size that I can only receive client.socket.receive. I can only receive 1024 bytes of data. Okay. And then I can decode this message, whatever I'm receiving. Okay. And then I can print here that received from the server. This message is received from the server. And then I can again type here message, this part, this part. Okay. And then I can close the connection if we exit the while. So client.socket dot close. And then here we can run the program. If underscore underscore name underscore underscore is equal to main, which is my main function. Then I can use here client program. This is my client code here. So let's save it, client underscore program dot py. See, let's understand this first and then we will run the server code. See, first we are importing the socket here, socket library. Then here I am creating a function. Okay. In the function, we have to provide a IP. Now, which IP we have to provide? Here we have to provide a server IP because we wanted to connect with the server. That is why we have to provide the server IP. Server
Mm-hmm.
IP because we wanted to connect with the server. Then
Mm-hmm.
port number. This is the port number I wanted to use. Okay. Then we have this client socket. Here I'm creating a object here. Okay. Then client.connect. I'm connecting with the IP and the port number. Which IP? The server IP. Port number, the server port number. Then here input. Now here I'm taking input from the client. Now client wanted to pass something, pass some message. So what I'm taking here, I'm taking the message from the user. So taking input as a message from the client. Then here I'm using message. Let's say the client apply message by, like by, or let's say the client apply by, like this one. So now by can be capital case or it can be in the lower case. So what I'm doing, I'm just converting my message into the lower case so that whatever the user apply by or like this by, I'm just converting this by into a lower case, BYE by, and then strip. Let's say the strip for removing the space. Let's say the user put like this one, by, a lots of space before by. So I'm removing the space from here and from here, from here. Okay, like we have this space and this space here. So I'm removing the space from either side and then I'm matching if the user apply by, if if the message is not by, if the message is not by, then run this loop. And if the message is by, then close the connection. That is what
Mm-hmm.
I'm saying. If the message is by, then close the connection.
Mm-hmm.
But if the message is not by, give me a second. Yeah. So if the message is not by, if message is not by, then run the loop. Okay. Then we have this send message. Now we are sending the message. So how we can send the message? We cannot originally send the message. Let's say I'm sending the message hi. So I cannot send hi. We have to encode a message. Okay, encode a message. Then we are sending the message using send and message over and then encode. Then here, whatever the message I will receive. So this is for, let's say I'm receiving something from the server side, some message. Okay, so that I'm receiving here using RECV receive function here, and the size should be 1024 bytes. So the message size should be 1024 bytes. More than 1025, I cannot receive. And then I'm decoding it. See, I'm sending, so I'm encoding, and whatever I'm receiving, I'm decoding it. That is compulsory. And whatever the message is, I'm storing inside data. Data contain my message, which I receive from the server side. And then I'm printing the receive from the data here. So whatever the data is, I'm just printing on the terminal. And then I'm again typing message. Okay, let's say the client type hi. The user, the server type hi again. Then I have to type again. Let's say, how are you? So that I have to type. And then I receive something from the server side and then so on and so on until I type by message. When I type by message, the connection will close. And then we are running the main function. Is it clear, this code?
Mm. I will try, teacher. I need to make a practice here.
Okay. Now we will run the server's code. We will create a
Mm-hmm.
file for the server. So I will create a new file for the server. Most of
Okay.
the code is similar to the server, to the client. So we will import socket again. And then we will create a function for the server underscore program. And then here, this is my function. Again, this will take a host as IP address. Okay, sorry. First, it will print the IP address, which is socket dot get host name. Host name. Okay, why host name? Let's say this will print the, or this will get the client name, client IP. Okay. Then port number, the port number is 1224. So you have to use the same port number, 1224, same port number. So let me save the file first. Server underscore program dot py. So you have to use the same port number as the client port number here. Then here with this port number, then we can again create a server underscore socket dot socket. So we are creating an instance. Then here we will print a message, which is waiting for the connection. We will print this one, waiting for the connection. Then we have to use a bind method. And bind method is server.socket bind. So we are binding the host and the port number together. What is host? This here comes the IP address of the client. Okay, because now the server wanted to connect with the client and the client wanted to connect with the server. Okay, so here comes the IP. And then here we will configure. Here with this server underscore socket dot list. Like how many devices we can connect with? 2 client. So we can connect 2 client at a time. You can provide 5 client as well. It's your choice. So for now, I'm mentioning 2 client. I can connect 2 clients at the same time. Okay, with 2 clients at the same time. Then here we are creating a connection, comma address. So here we will connect accept the socket dot accept. We will accept a new connection. And then here we will print connection from this particular address. Here comes the address of the client. Okay. Then here we will run the main loop while true. Here we will receive the data from the connection from the client. And whatever the data we are receiving, that should be also of 1024 sites. And then we are decoding the message. Okay. Then we will see if not data. If there's no data from the client side, then we will break the loop. Okay, if there's no data from the client side, then we will break the loop. Then we will print here. If there's some data, then we can write here from connected user. And here we will apply the data. Okay. Then we will write something. Okay, we also wanted to put something as a server. So we can also take user input from the server and then we can send the data. So here we are receiving first and then we are sending. In the client, we are sending first and then we are receiving. Okay. So this is my client and then we can close the connection here. If there's no data, then we can simply close the connection. And this is optional here. It's your choice if you wanted to close the connection on. And then we can run here if underscore name is equal to underscore v. And then we can run the program. This is my server code. Okay, this is my server program. So I know this is a kind of a typical here. So let's understand first. We are importing the socket. This is again my function. Now here we're getting the host name, means we're getting the client IP. Okay. Then here we are getting the port number. And then this is my socket. I'm creating an object here. Then I'm printing this message that we are waiting for the client. Means first we will going to run the server code. And the server will wait for the connection from the client side. And then if the connection comes, then we will bind the host and port together. And then we will listen. This is for listening. Like we can listen or we can say we can connect. with
Mhm.
two clients at the same time. Okay. You can connect two or more clients as well. Then we are accepting a new connection here, and then we are printing the message here that we have connected with this particular address. And here comes the client address. Then here we are running a loop, and first we will receive a message. We will receive a message from the client side. From the client side. So whatever the message we are receiving, we are decoding the message. And the message size should be 1024 bytes. More than that, we cannot accept. And then if we have no data, then we will break the loop. And if we have some data, then we will run this message. If we have some data, then we can print it. Okay. And then after taking input from the user, like after receiving the message from the client, we can send some message. So we can, like the server can send some message.
Mhm.
And then we are sending the message here, send data to client. So we are taking input from the user, from the server, and then server can send some message. And then at last we are closing the connection. Okay. And then we are running the main program. So this is my server code. So now I have to transfer this server file to my server. So the server I am going to use is my Linux server. Okay. So that we can connect with the client and server. So I will going to use my Kali Linux machine here so that we
Mhm.
can connect with the server. So for now,
Okay.
let me make some settings. Okay, so what we will do, I will just transfer this file in my
Mhm.
Linux, just server file, .pro. Okay. Now first I will going to run the server here. So first I need a IP address for the of the server so that I can fill in the client side.
Yeah.
Just a second. So here I will first open the terminal. ifconfig. So this is my IP address on my server. Okay, so I will copy this and I will paste here in the client IP. Okay, and yeah, now we are ready. And here I will simply clear here. I will use sudo for becoming a root user, and then I will move on my desktop. Here I will run my file Python 3 and my file which is serverpro.py. So now you can see waiting for the connection. Now we can run the client code here. This is my client code, and I will click on start. Sorry, just a second. I have to remove the file machine actively freeze it. Okay. Just a second. Then we want it up here as well. And I've run this file while client not paper. No connection could be made because the target machine activity first used it. Why the target machine is different? One second. What we can do, we have to modify the server file. In place of here, I have to put the IP address of the server. Okay. So let's see. What is the IP address? This one. Okay, now I think we can connect. Waiting for the connection. Okay. Now here we have this client. And now you can see the connection has been established. Now here I will type C. In the Linux machine, you will notice connection from this is my Windows IP. And I have successfully connected. Okay. Now if I type here hi, you will see message here from connected user hi. Here I type hello. Now you will see the message here. Hello, received from the server. Okay. If I type here how are you, and you can see in the Linux, you can see how are you. I am good. You can see here, I am good. If I type here bye, you will see the connection has been terminated. Here also, you will see connection has been automatically terminated. So this is how it is working. It is like a chatting app. A person is chatting with the another person. It is like a client is communicating with the server. In this way, you can also share the files. So this is a very simple, like a client and server program where the client can type some message and share to the server, where the server can also type some message and share to the client. We can also implement here few features like we can share the files, we can share the images, we can share some other parts, etc. So we can share everything. So it is like a very simple program where we are sharing the message to the client and the server is sharing we are sharing the message to the server and the server is sharing the message to the client. Okay. Is it clear?
Yeah, teacher, I need to practice this this servering. So teacher, the if I want to create a client, no, a server, any if I have a Windows only, I don't have a Kali Linux, so I can use Windows, right?
Yeah. See, if you wanted to use Windows, then see what you can do. You can, in place of this IP address, this is my server IP, apply the IP address of a Windows IP. So let's see. My Windows IP is this one 192.168.29.96. So let's copy this. And here I'm pasting my Windows IP only. And in the server IP, here I'm just, you can put here get host name. Okay, for getting the client IP. So just keep this as it is. See, if you are running the server and client program in the same machine, so you can use get host name. But if you are using in the different machine, then in the server, you have to put your server IP as well. Here, this is the server IP. Okay, so here I can put, this is the server IP. But if you are running the code in the same machine, so here comes the client IP and here also comes the client IP because we have one client only. Okay. So what I will do, I will run this code in the different window. So here I will run my client program and in the second window, I will run my, I will use a new window here. And here I will open my file. Okay, so I have two window now, server window and client window. So let's keep this side by side. So this is client. Now I will run this code here. first we will run the server code. Okay, you can see waiting for the connection, and here we will run the client code. So again, we will open the window. We will move to desktop. And here I will run Python client pro.py. No connection should be made because the client machine refused to accept it. Why? Phone number is okay, client is okay. Let's see. Here we can use client IP as well. Okay.
Mm-hmm.
We wanted to run server, and here
Mm-hmm.
we can run. Yeah, now see it is working. So here you can put your Windows IP in the server also, and in the client also you can put your server IP.
Mm-hmm.
Both. So you can use hi, and you can see from connected user hi.
Mm-hmm.
Hello, this is my server. You can see received from server hello. How are you? How are you? Like this one. And here I can type by. Once I type by, you will notice the connection has been terminated here also. You can see
Mm-hmm.
the connection has been terminated here also. Is it clear?
Yes, teacher. Thank you very much.
So if you wanted to run in the same machine, just put in the host the Windows IP at both places and run in the different window. And if
Yeah.
you're running on the Linux, then you have to put the Linux IP here and the Linux IP here, like same IP at both places. Okay, like the server IP. These are like a kind of server IP. This is also server IP, and this is also server IP.
Mm-hmm.
But in our case, the client is all the server only. So that is why here we are putting the same IPs. Same as if you are running in the Linux machine, then you have to put the Linux IP on both the places. Okay, is it clear?
Yes, teacher. Thank you very much.
Okay, so tomorrow we will going to do a project on
Mm-hmm.
the printer and on the GUI programming and on the this particular
Mm-hmm.
networking. Okay,
Yes, teacher. Thank you.
any other questions?
No, teacher. Thank you.
Okay, so rest we will continue tomorrow. I will share the file so that you can practice.
Yes, again. Thank you very much again.